All right, guys, this is the presentation we went through last night on the night organized by Volker. Awesome that so many people turned up and there was a good response to it. So I'll try to go through the presentation a little bit faster than we did last night to make it not too long. Obviously, if you get any questions, plenty of people to ask. So what did we go through? The first thing we went through is like all the apps and websites that I use in this case to get the data that we need to determine if it's going to be a good flying day or not. So wind direction, strength, thermal height, cloud cover, how cold it will be up high. And after I told you how to, like where I get the data, then have a quick chat about how to interpret the data. When is it a good day? What do we look at? Talk about Bakewell mainly with some examples, and then also at Quinns, which you can sort of translate to anywhere on the coast. I did have prepared a number of other slides with, topics that are come up, but not necessarily have to do with the weather. About Fly Sky High, airspace, live track, the WhatsApp group, and tone squelch. But we kind of ran out of time last night, so we'll keep that for a next time that we do a night like this. So I won't cover them in this presentation either. So I'll keep them fresh for the next evening we might organize. All right, so the apps that I use, I've got them in a folder in my iPhone, and I'll quickly run through them from left to right. So I've got Spedmo, which you can see like it's not actually downloaded, but like it's an app I've got an account for. I upload all my flights to that just to have a record online somewhere. It does a bit of analytics on your flight. To be honest, I don't really look at it too often. I'll have to have a look. Fly Sky High is the flight instrument I use. It's the only flight instrument I use, and my last flight I realized the downside of that. If your battery pack doesn't work properly and you have a long flight and your phone dies, then you're kind of screwed for your points. Windy is the free app that a lot of people use. I use it mainly for the sounding and sort of wind direction. I'll get to that. And then the Windy app you see here is a paid for app, which kind of gives you the same information, just you can organize it a little bit different, where there's a number of models for wind speed, direction, cloud base, and clouds. So we kind of discussed yesterday, like one of the big things that sometimes people don't get. They think that these different apps have different, like give you different forecasts. They sometimes do, but they're generally one of like 4, 5, 6 different models that I used over the world. This Windy app just puts all these models together, and you can sort of see how they, how they relate to each other. And most of the apps you find online will pull some of the data from like some of these models and give you that. So they've got Willy Weather, which I use for the actual recorded weather. So if I want to see, especially flying on the coast, Rolf's Muppet Forecast, which is run by Rolf. I'll go through all of these individually. And then I've got a number of, these are actually websites that I saved links on my home screen and I put them in a folder. So XC Skies, which I discovered recently after somebody, can't remember who, posted a picture of them online. It's also a paid subscription thing, $39 apparently a year. Up to you if you think it's worth paying that for it, but it does get you the thermal height and strength, which I thought is kind of handy. I've got a link to AirCheck, which is just a site where you can upload your track log to see if you violated airspace. X Contest, so there's a competition running like all over the world, but then also like like you can select for Australia. There's you can select for like the place where you fly, so you can sort of see how you rank currently when you upload your flights. Then we've got WA Fly Sites, which is a link that has a lot of the flights around like sites around WA where you can fly with a bit of an idea of like how to get there, like who should fly there, who should not fly there. I'll provide a link to that in the list of links, which I'll upload with this presentation. And then we've got LiveTrack 24, which I use. So LiveTrack 24, for those who don't know, is basically like a website or a server that you can upload your like live upload your location to. So I use FlySky High. FlySky High connects with my LifeTrack24 account. So when I'm flying, my altitude and location is every 2 seconds or every second gets sent to LifeTrack24. So online you can, anybody who's got these links can see me fly in real time. So for instance, if I've landed, I open up one of these links and I can see if guys is still in the air. I can see where he is, which direction he's going, how high he still is, and with that makes the retrieve a lot easier. It also allows me to, because it connects to FlySky High, I can add somebody that also has a LifeTrack24 account to my friends list in FlySky High, and then I can see them while I'm flying, so you can see what their location is. Now, in general, a couple of things, like even though you can get super proficient in reading all these weather apps, there's never 100% certainty. So these models by themselves, because they're models, they're not without fault. They take measurements like far away from York and then interpolate that to predict what it will be like in York, and then they try to forecast that for like a week out sometimes. So, there is like a pretty big margins of error in there. The only thing we kind of want to see if there's a good enough chance that it's good. So if we're going, are we wasting our time? Sometimes you just have to take the chance, because if you're not there, 100% you won't fly. So there you can go very deep in all of this, but if the general overview looks okay, then I generally just go and see what it's like in time. All right, so the first app, Windy app, so I'll start with that. So that's the paid version. I use that mostly because I can put everything I need there like in one screen. And most of the time when you see me post something online on Facebook and saying like, hey, I think this day is a good day, you'll see a screenshot of this, because it gives you for whatever day it is at any given time, like during that day. It gives you the wind speed, so like in kilometers an hour. Like I don't really do knots, so if you're a knot person, definitely if I screenshot something, you have to translate that in your head. So in this case, like the different models, the different lines here are the different models. So Icon, GFS, ECM, like people know a lot of stuff about that. I don't. I just look at these models and say like, hey, the spread between the different analytics is either small or big. As you can see, the wind direction here, like between the different models, they're all pretty much in agreement. So that for me shows like, hey, it's pretty certain that the direction will be that way. There are days where that direction is it's like 90 to the 180 degrees, like a different direction, and then hey, there's a fair bit of uncertainty of what the weather will be like. Then also underneath here you see like the little cloud. It's the cloud base where we can like at what height we can expect clouds, which often translate fairly closely to the topper lift. So how high can we get? If this is very low, not great. If it's higher and like generally, above 1500, 2 kilometers, then that's a nice sort of height. That's what I look at here, and then underneath you can sort of see here these little clouds, high, like at different heights. So high clouds, medium, and then there's a low level of clouds. So it sort of depicts like where can we expect clouds and where. Then these little dots here, if there's rain expected, there will be like an amount of millimeters of rain that we can expect around about that time, and then the temperature of the day. So between all these different things, that tells me pretty much in one visualization, like, hey, is it worth going for me or not? Is it likely to be good? Then I show this. Guys likes to use windguru.cz. Point of it was that it gives all the same information, just generally a different bit of layout. And there's plenty more apps and websites where you can get the same information, just slightly different layout. Just get used to one of them so you can work with them pretty well. Guys likes this one. As you can tell, it doesn't give you hour by hour, but like at 8, 11, 2, 5, and then 8 o'clock at night again. So it's these middle ones of the day that are, most of interest. He would look at the colors, because by now he's internalized like which colors are good. So you got the wind speed here, the predicted wind speed, then the predicted gusts, then the predicted direction, temperature, and then at 3 different levels, the height and like thickness of clouds. So this whole section here is for one of the models. If you scroll down on that same website, you'll find the same information given by a number of different models. So you'll get the same information, just slightly different layout. It's just a preference of which you like to use. All right, so the windy free version. So the one with this logo, a lot of people use this. I use this to sort of like over the route that I think will be flying, or the direction will be flying, seeing like, hey, how things change over time. So at the bottom of that windy app, you can see like at what time it's now selected. So in this case, Monday at 9 o'clock in the morning is when the wind is, going this direction, and has about that wind speed at that location. So this little heart here is York. So if I'm flying from Bakewell, I'll have a look over, the direction of flying. Like in this case, you would fly with the wind sort of that way. So it tells me like at 9 o'clock, if I were to take off, I would get probably pushed towards Canada, which then makes me think, a bit of airspace coming up. The good thing with that windy app is if you click on like the little menu icon, which is normally around about there, you get this menu popping up from the side, and this little slider here can give you the forecast at different heights. So I usually look at like just surface level or 100 meters, usually not that different. And then I slide it up to, let's say, like a 1500 meters, because sometimes if the wind is at the ground is so in this case in the westerly direction, like from west, it might sort of shift further from south, which means that like once I'm up, I'm actually flying more towards the north than towards the east. Okay, so I use this to sort of plan like my route, like how will I fly like over time. So, and then obviously like you can slide that over the day. So like if I expect to take off around 11, I'll look at what like at surface level the direction is, and then I might slide to like 12, 1, 2 o'clock and see how the direction changes, and have a bit of an idea of like, hey, which route or route points should I sort of program in to get a bit of an idea where I'm going to fly. Okay, when you push your finger on the map and hold it there for a second, so in this case you see the little dot there, like I pushed that for a bit, then this little menu pops up. I also look at the sounding for, or like a SQT diagram, but a sounding to have a look at what the day will be like. Now, not everybody was very versed on like how to read the sounding, so we went quickly over that. I'll try to give you a quick overview. There's plenty of YouTube videos that go into way more depth, and are probably better at explaining this than I did, but here's how I understand it and what I look at. The sounding can sort of give you an idea of like what the day will be like what the thermals will be like, what the top of the thermals will be like, how cold it will be up top. I'll show you in a sec like how you can read that. There's all other apps that you can find all that information out from, so you don't really need to read this, but if you can over time, if you slide this slider at the bottom, you can see how the day progresses. You can see like how the top of the lift, how the top of the thermals, how that progresses over the day, where there's an inversion, etc. So it is like a good way to see how the day goes, but there are other ways to do this. Now, let me give you a quick introduction as how I understand what you see here. So the first what I'll do is I'll show you the different elements here, and then I'll go over what they mean, like how you can read them for what the day is. Now, the red line is the main line that you kind of want to look at. So that's called the sounding. You can imagine that being if you let up a balloon from the ground, it will measure at every height. So on the left you got altitude. At every height it will measure the temperature of the air. So as you can see here, like that measurement, in this case will be a forecast of course, but let's say the measurement shows that like when you go up the first little bit, the temperature drops pretty quick. So from the 17 degrees on the ground, it drops pretty quick. Then it drops a little bit less quick, a little bit less quick. And here from this point on, you can actually see if you increase altitude, you actually slightly get warmer. Now that's called an inversion. You see that a lot in Bakewell in the morning when there's a warm layer of air sort of slowly rising, which can be hard to push through if a thermal comes up. And then from here, like it starts to follow the line you predict. Like the higher you get, the colder it gets. So the blue line here is the dew point. So basically at which point, at which temperature, at any given height, will the air start to, will clouds start to form, will moisture start to come out of the air. So that's a hypothetical sort of dew point. Now, then the next line of interest is this gray line. Like that gray line could sit like anywhere on this chart. I'm not entirely sure why it's drawn at the point where it's drawn, but how I look at it, so that's the angle of that line. That's the one you want to sort of remember, because that gray line is the dry adiabatic lapse rate. So that's basically a difficult term to say, like, hey, how fast does a pocket of air cool down when it goes up? So when air rises with a decreasing pressure with altitude, because the pressure decreases, the temperature of that parcel of air drops. Now the rate of that drop is 1 degree per 100 meters. So if a thermal forms on the bottom, it starts to rise and it basically drops in temperature by 1 degree per 100 meters, which is that gray line angle. You can see like at this stage that angle changes, and I think that has to do with then the cooling is not only due to the reduction of pressure, but also has to do with then you get some evaporation and then like condensation going on, which means that there's some heat generated, so it doesn't cool down as quickly anymore. But this bottom gray line, that's the one I mainly look at. Now there's different wind directions and at different heights, so you can see like, hey, how does the wind direction change with height? I don't really use it in this picture, but you do have all the information there. So for somebody adapt to reading those, you get all that information in this one picture. It also gives you the LCL here, which I generally take is roughly cloud base. There's other models that show you top of lift, but that gives me generally a good enough indication if the top of lift is going to be high or low. Okay, so how do you read this? Like, how is this relevant to any case? Like, you have to sort of understand like how thermals work and form. So to keep it simple, if air is hotter than the air around, the surrounding air starts to rise. Same as a hot air balloon, hot air rises through cold air because hot air is lighter. So if on the ground there's an area that, the sun radiates on it, and then it radiates back more heat than the surrounding air, you get, for instance, on rocks or on a dark field, that air gets hotter than the surrounding air. So the surrounding air at the bottom is expected to be 17 degrees. So, and since at York, that's actually at 221 meters above sea level. Let's say in a certain area, the air actually now gets heated to about 2 degrees above that. That 2 degrees difference, that's generally enough for thermals to start forming. That's enough for the surface tension to not be strong enough to hold that bubble of air on the ground, and the bubble of air will start to rise. We can go deeper into the forming of thermals and why they can be more or less, but to keep it simple, 2 degrees difference. So you've got an area where there's the air is 2 degrees hotter, so that air starts to rise. Now what happens with that parcel of air? As we said, that parcel of air starts to cool down at the rate the same parallel with this adiabatic the dry adiabatic lapse rate. So, you know, at 100 meters, like it's 1 degree cooler than the 19 that it started with. So this is the line that that thermal will form in terms of cooling down with altitude. Now you can see here that the surrounding air in the beginning cools down faster than that parcel of air. So like the difference goes from 2 degrees to actually more than 2 degrees in the beginning, and then stays at 2 degrees, and then the surrounding air actually starts to get closer to the temperature of that thermal until they meet, and then the surrounding air and the thermal have the same temperature, which then there's no more reason for the thermal to go up even further. Now you can burst through a small inversion because the rising air has some momentum, but to keep things simple, once it reaches the same temperature, you generally, it doesn't rise any further. So obviously the bigger the difference, the more strength you're going to get. So you generally see that they're closer to the bottom, like those thermals are not as strong again yet. And then once you get to a certain height, like you start to gain a little bit of strength, and then towards the top it gets weaker again, which kind of makes sense. And if you have ever thermaled, you've experienced that. So that's how you can sort of read this. So like if you start drawing a line from about 2 degrees to the right from the sounding, and then you draw it up parallel, you can read that like the top of lift is in this case like very close to 2,000 meters. Obviously very much eyed in and not super accurate, but it gives you an idea. Like if it's 1,000 or 2,000, you can definitely see that. Another thing you can then also see is like, hey, at that point, how high will I be? Like the surrounding air, the temperature as well as the thermal will be in this case just over the 0 degrees. So you're probably sitting at 2 or 3 degrees. So yeah, it can get pretty cold. Okay, so that's the main things you'll get from this. You can also get an idea of like if there's clouds, if there's likely to be clouds forming. If this blue line, so if the dew point gets close enough to the actual temperature. So generally, I've been told like between like with a 2 degrees gap, if it gets within 2 degrees of the actual temperature, you'll start to see condensation. So you start to see clouds forming. So if that blue line gets very, like at any point, very close to that red line, at that height, you could expect some clouds to be forming. On the flip side, if that line stays well away from, like more than 2 degrees away from that red line, you can expect to be there a blue day. All right, XC Skies. So XC Skies, I believe it's .com. I'll give you the link. Gives you a map. It's a paid app, so it does give you. It does cost you about $39 US. Volker looked up last night to pay, but I'm still on the free trial, which obviously if you get multiple email addresses, I didn't say that out loud. Anyway, just pay for the subscription if you like to get this info. You can see like they also can give you a SQT, but you can get that for free. The SQT is another word for the sounding. It's actually the name for the diagram that they use. Don't want to go into that. But the thing I find interesting is the point cast, because if you click on that, you'll get this diagram, which you can zoom into to get the thermal heights and the thermal strength on those days, which I find quite interesting. So Monday, Tuesday, as you can see, the top of usable lift is that red line. So it starts at 8, ends at 6, 8, 6, 8, 6. Generally in the day, which makes sense because daytime is when the thermals start to form. So it's not super precise, but you can zoom in. But the thing is, like, you can get a good idea of what height you generally will be flying at in the middle of the day. So in this case, just under 1800 meters, and like Wednesday, you're likely to get even higher, although that's only in the afternoon, early on. And looked at this a couple of times and it's been pretty accurate. So it gives you how high you usually can get. It also gives you like how aggressive the day is likely to be. So in this case, the strongest part of that thermal, and as we've just seen, that makes sense that that's sort of like in the middle. goes like between 4 and 5 meters a second, which is not a super aggressive day. When you get something in the red, then you know like you're in for a treat. All right, Willy Weather. So the Willy Weather app, as I said, I use that mostly or only to check, hey, if I want to go to Quinns, what's the forecast and what's the actual weather reading like. So the forecast in Quinns is obviously computer generated, but the real measurements like don't actually get done in Quinns. The closest one is Ocean Reef, which you'll see, which is still 10 kilometers away, so there might be a bit of discrepancy there. Volker pointed out yesterday, which is a good point. You can also look at the Rottnest info, which is obviously like out front, and once you see what wind changes in Rottnest, you can expect that similar sort of wind about 20 minutes or so later in Quinns. So if you're sitting at home and you're like, it's a bit on the strong end on the forecast, and all the actual show like it's actually even stronger than forecast, I might stay home and not go, or the other way around. So that's what I use Willy Weather for. Then Rolf's Muppet Forecast. So again, I'll provide the links, but the link is basically lambdatabase.com/Muppet Forecast. Not sure if everybody knows Rolf. Rolf has moved over east, but he used to fly over here, and he pulled his own like RASP data from from websites or something, and then he ran his own algorithm, which only worked in Bakewell, and he's now done one for Mystic as well. So since he moved that, so make sure you got Bakewell selected, and it only works for Bakewell, but it does give you a very easy way of figuring out like what the day will be like without having to do many analysis yourself. So it's literally like meant to be a Muppet forecast. So Rolf gives you the direction and the speed of the wind on the ground, and then also immediately gives you what that means. So 32 kilometers an hour west-southwest on Monday the 11th. The 1st of November in this case at 11 o'clock. He gives it for 3 different times during the day. I believe it's like 11, 2 or 11, 3 and 5 or something like that. So you can see over the time of the day, like, hey, sometimes this is strong in the morning, but then it gets better in the afternoon. So it gives you, hey, how you should interpret that. So if you don't want to read any of the other apps, obviously this narrows it down to like a very little bit of information, but it does give you a good idea of like what he thinks. It gives you the thermal height only for that time, and if that's a good height for IXC or not, with a little picture that immediately tells you if it's shit and only good for wingsuits. The thermal quality, not sure how to quantify that, but the updraft velocity, so I would imagine that's the strongest sort of updraft you would expect around about that time. So the lift, 2 meters and 85 centimeters a second. The temperature, if it's cool, and then like how cold you might expect it to be in the air. So should you wear your gloves or should you fly in your t-shirt, which Jason told us they used to like to do so they can feel the temperature. Well, if I know it's going to be fucking cold, I'll probably just put a jacket on, just in case, and put my hand warmers in because I'm a pussy. Then you've got and the XC potential. So he translates all of that information to like, hey, what should a good pilot be able to do? If it's obviously light winds, then the triangle option would be possible. In this case, a 9 kilometer triangle, which is not very far. So that's, like 3 kilometers, 3 kilometer legs. So you can push it by 3 kilometers into wind, which is obviously a function of like there being very strong winds. So like that's not a very good triangle day, but it's a good downwind day. So by all means, it's a good forecast model. So when is it a good day then? Obviously Rolf's forecast model tells you that right away, but it's also important to realize that a good day for one person is not a good day for another person. You got to know what kind of pilot you are and what you like, and what you're capable of. So obviously good days on Bakewell can be either good days for like XC going cross country, or it can be a good day for soaring on the hill. And they're not always the same days. Sometimes they are. So some days are great to get up and get away from the hill. But if you just want to fly up and down the hill, it's not a good direction, or it's not the right, the right conditions for that. Now, some people like it sporty, so especially in the heat of in the middle of summer, like it can get like pretty bumpy around Bakewell. Some people do like that. Some people don't, or would rather fly in like calmer air. So for somebody to say like if it's a good day at Bakewell, it might be great for them, like the conditions they like to fly, but for others maybe not so much. And then obviously like especially like on the coast, but also in Bakewell to an extent, is if you have different size of wings. Somebody might say like, hey, it's going to be awesome at Quins because they've got a 16 meter little mini wing with their 100 kilos flying weight, while if you rock up with your full size wing, like you got no chance of staying on the hill. So it is important to be able to translate the data that we just seen to like, is it a good day for me? And if you do ask the question online, and I would highly recommend you do, especially if you're not super experienced just yet, ask somebody but tell what it is that you're after. Don't just ask like, is it a good day for flying? Because then you don't know if it's going to be good for you. So you need to juggle several elements to predict if it's a good day. So the wind speed, direction, thermal strength, and for the thermal strength, well, there are these apps that we just spoke about. For me, as I said, like I generally, that's a bit of a feeling that you build up over time. When I know the day is, it's been pretty wet, or there will be a fair bit of overcast, then in my head, like I know like these thermals are not going to be super strong, or I expect them to be super strong. And I might be wrong sometimes. But like if it's very wet, that dampens like the thermal activity because the ground just absorbs a lot of that energy. If there's a lot of overcast, then everything just heats up a lot more evenly. So that doesn't give you a lot of like difference in temperature. So that doesn't give you a lot of thermals. And I did put winter time there, but like there's definitely times in winter, if it's nice and sunny, even if it's cold, it's the difference in temperature, right? So as Volker pointed out yesterday, even in winter you can have good thermal days, but they just never tend to be as aggressive and strong as they are in summer when the sun is, directly overhead, blasting straight down, and all that energy is like focused on a very small part of the ground. But even in winter, even with the sun being lower, you can still get decent thermal days, but you will get a bit of, over time you have to get a feel for how strong is it and how does that relate to like what the day will be like. Now I've tried to put that in a little bit of a graph to explain this, and I'll try to go over this like relatively fast, maybe just pause it to not make this super long, because I do apologize, it's already like half an hour I see. The wind strength versus the thermal strength. So I'll try to go over sort of the extremes. This extreme ends when it's still sort of flyable. And then obviously like everything can be sort of in the middle, and like where it's in the middle and if that's good for you, that's something you have to over time get a feel for. So starting with the hardest bit, if it's weak thermals and the wind is weaker, so the wind is very predicted to be very slow, and I think like, it's been overcast, it's been a bit wet, I don't expect these thermals to be very strong, then I look at it as like, okay, so there's no ridge soaring because the wind is not enough to stay up on the ridge. The thermals are going to be hard to catch because they're going to be small, they're going to be weak. They might be broken up, so there might not even be like proper columns, there might be just bubbles. And they don't get blown up the hill, so like you kind of have to launch into nothingness and hoping you catch something. It's a very hard day to fly. Not ideal. There might be a day I'd rather stay home, possibly. But sometimes, the forecast is wrong and the wind is actually stronger. So then when the strong thermals come in, so there's a nice and hot summer day, like everything is looking good, it's like blue skies, it's nice and dry. but the wind is still weak, a weak day, then I look at this like, okay, so what do I know about this? Like there won't be much ridge soaring because the wind is too weak to be, to have ridge lift. But if I can get up, like I can get a possible XC, but it's not going to be a record day. Thermaling could be easier because if the thermals are big and strong, they're going to go straight up. So there's not, they don't get blown out too much. So like once you find a thermal, like the thermaling might be relatively easy. But those thermals won't be blown up the hill. So like obviously a thermal has like quite a lot of mass because a rising packet of air might seem light to you, but like weighs tons. So the wind actually doesn't push those massive thermals up the hill if their wind is not strong. So that means that like when you launch in weaker wind, even on a strong thermal day, you might have to launch into no wind, nice forward launch or something, and then hope you find one of those stronger thermals. Now on the pointy end of both, so like when the wind is strong and the thermals are strong, obviously like when the wind is strong but not too strong, you can ridge soar, which is great. So you can stay on the hill, which means you've got a number of times that you can try to catch the thermal, and if you miss it or you fall out of it, you can just fly back to the hill and get another go, which is great. So when the wind is strong though, like thermals can get sharper. So if the wind is strong, obviously, and the thermals are strong, the stronger a thermal is, so the bigger it is, and the stronger it up, the straighter it gets. But like with the wind being stronger, then the angle of that column can get slanted again. Now with strong wind, the weaker part, the outside part of those thermals get blown away a bit more than the strong inside core, which means if you fly downwind, you hit a thermal, but because all the weaker stuff is sort of like blown to the back of that thermal, you fly straight into the really sharp end and the really fast moving end of that thermal. That can make it quite sporty. So you go from sink really quickly into like your 4 or 5 meters a second up. So that difference can make it a bit jarring if you're fairly new to this. And while it can also be a lot of fun, it's not for everyone. So if the wind is strong, too strong to take off in the prevailing wind, those strong thermals give you that window to actually launch. So those thermals block, if there's a thermal out front of the launch, it blocks the prevailing wind for a bit, or just enough so you can get up, launch, and like launch into that thermal. Obviously you do have the risk of getting pushed over the hill. If it's too strong, you can fly your mini wing. Not a lot of people do, but it's definitely the people that do rave about it. So it's definitely worth having a smaller wing once you're ready for that. And your ground handling and launch need to be on point, because if those cycles are relatively like short, in that short window that it's that the wind is just lulled enough, you need to be able to pull up, launch, and properly fly away from the hill. You can't fuck around for too long, because if the wind comes back on and you're halfway up, you might get blown over. So on those days, definitely good to ask more experienced people, like, hey, what should I do? When should I launch? And time that well. And then the last of the corner, when the wind is strong and the thermals are weak. Obviously, when the thermals are weak and the wind is strong, like those little thermals will get, if they're even columns, which they probably won't be, but like they will be super slanted, which will make it's just harder to stay in them. The thermals will be broken up, so that you get like little bubbles of lifting air, but not like solid columns, which makes it very hard as well to get up. And if the wind is too strong, like you might have the risk of getting pushed over the hill. So then you might want to fly a smaller wing, but then flying a smaller wing and having weak thermals, you get more of a speed riding down to loose type of situation. So, and obviously, like all these extremes, like there's stuff in the middle that makes it either a good day or not so much for you. So, and then the last sort of thing is like over the top of all of that, you'll have a number of considerations that can push it one way or the other. If the day is looking great and the top of lift is high, then that's a great day. But if the day is looking meh, it's already like wind is kind of weak, thermals are kind of weak, and then if the top of lift is also like set to be like 1100 meters or something, which is relatively low, then it's like, well, you can't even get, if you do get high, like that's sort of the highest you're going to get. It's not going to be a great day for, for flying away. Inversions. So as we looked at the sounding, like if you see like an inversion, you kind of can see like on the sounding what time does that go up. So sometimes it starts early in the morning when the inversions are like 800 meters. No real point in launching then, because you hit that inversion early on and it's hard to stay up in that. Airspace, so certain wind direction in the future we'll touch on airspace a bit more, but obviously like if you get it from Bakewell, if you fly west, so if you get an easterly wind, you get pushed towards like airspace, which can limit your options in terms of XC. And then the wind direction, is soaring an option. We'll go over that in a minute. A couple of things I've noticed, and that might be wrong, or but like I always get a feeling that the real life situation in Bakewell is the wind direction is generally a little bit more clockwise. So if it's predicted to be north, there's a little bit more west in it, so it's a bit more east. The direction you fly in, than the forecast. So I generally keep that in mind. Plus, the wind strength I find is generally more likely to be lighter than stronger. So if it's a light day in the forecast, then I expect that it's basically like a none day, and the other way around. But that's not always the case. Just giving you the little things that I found. All right, so when is it a good day on Bakewell and when is it a good day on Quint? So as you can tell, like sort of like turned those W's, which I had written wrong there, sideways, so they're east. So southeast is bang on the ridge. It's soarable, easy to stay up, because you don't, even with fairly light winds, because it's so straight on, the same as on the coast, that gives you an opportunity to fly up and down in the ridge lift, and you don't even really need thermals. If it gets south, and if you've ever been to Bakewell but maybe never noticed, those 3 roads that run through straight through town, which you can see from the launch, they're directly north-south. So like if the wind is parallel coming from those roads, then it's a bit skew on the hill, but still that's okay to get enough ridge lift. And there's a number of plenty of faces and bowls that are straight into that direction, so you get plenty of lift still. So south is still good, and south is also a great direction for cross country. The more west there's in it, the more and more you'll get that the wind is not coming up the hill, but just gets sort of deflected like along the hill, and you'll find thermals go, don't come up the hill, but they just go that way. You also get with these outcrops, you'll have to start being careful. And from the launch, obviously we've got that the main peak here that can give you some rotor behind there. So you got to start being careful that you don't fly into rotor. Anything like up until south, you don't really have that issue. All right, so the hill takes quite a bit of east, so east-southeast, still fine. Plenty of sort of bowls that you can fly in. There's not too much rotor. This one is actually fairly shallow and low, so even there, I haven't really had issues with that. But that direction is not ideal, as I said, because further up down there you could get into airspace. So if you do come for an XC, it's good to stay on the hill, but maybe not the greatest day for XC. Or if you want to do a short one towards 2J or something, you'll be good. All right, so some examples of flying in Bakewell. I'll go through this pretty quick. Basically, these are screenshots of days that I've flown in the past. And I'll quickly go through these. Direction, south, 15 kilometers an hour, decent cloud base, light clouds expected, light winds. What do we reckon of a day like this? Pause it if you want to have a quick look, and then I'll show you. This is the flight I did on that day, which is not fantastic, but The direction was correct. The altitude, I got to 1.8, which is a little bit higher than they forecasted here. And then the distance I did was 26 kilometers. So I landed this is Northam here, this is York. So I just landed between Northam and Grass Valley, which seems to be a little bit of a sinkhole as well. But the others flying on the day did sort of the same. Another day here it's a little bit more west in it, so still decent for, not crazy enough not to take off, but maybe not ideal for staying on the hill. We've got a little bit of a range in wind speed, but none of that which worries me. The 42 kilometers an hour gust might be something to watch out for. Just making sure you don't launch in it. And then the cloud base goes like up to 2 kilometers later on. A little bit of clouds early on, and it's again not super hot. So what do we do on this day? And this day I managed to get away very decently, and did almost 86 kilometers horizontal distance. So while I started off going fairly north, a little bit later on, like the direction changed very much into what you would expect. I got up to like 1.7 kilometers high, which is right in the middle of that 1.42 that they forecasted. So it's not that far off. And then finally a day where it's a bit southeast, winds relatively strong for some, like in the 20s or the high teens. Cloud base 1.3 kilometers, a little bit of clouds, but also a bit of rain expected, possibly, and not a very warm day. So what do we expect from that? That day was a bit of a non-day for me. Doesn't mean that it wasn't a good day. Somebody else, I don't know exactly what happened on that day, but somebody else might have flown like a very good flight. But I just wanted to show you. So the direction ended up being very much as forecasted. So still going in the direction of Northern, but definitely in that northwestern direction. Never really got up that high. So 1100, so this is at 12. So at 12 the top level was 1.3. I got to 1100, so that's maybe because I'm not great, or this was a little bit off. My maximum ground speed was 70 kilometers an hour, which is relatively fast. So the wind at some stage would have been more than was forecasted here. So I might have had a gust, or maybe up high it was a bit stronger than at surface level. So I generally look at my my track log, which I get from from my FlySky High, and I put it up to Google Earth. So I generally like have a look after my flights, like say how did I do, like what did my thermals feel like, visualize like what the day was like, and also what I did wrong, like how my thermaling went. Am I falling out of the front of the thermal? Sometimes I thermal too much into wind and I fall out, on the upwind side of the thermal, and then I fly. Like I think like I lost it, and then I fly away, and then I catch it again, which means that the thermal is more downwind for me than I expect. So by doing that over time, you start to get a feel for, this is how I should adjust. But also you start to get a feel for like, okay, when this is, this was a screenshot before this day, which I had saved. And then you see like, hey, this is what the day was like. Sometimes it's like, it's well off what you think. But you start to get a good feel for like, hey, what's a good day, what's not. All right, quickly going over quints. So 4 quints, as you can tell from this Google Maps shot, it's not bang on, it's not exactly west actually, it's just a bit south of west. If it's further off, so like the more angle you get on the beach, the more wind you need to still have that same amount of lift. Okay, so if the wind is light and it's bang on, you don't need as much wind, but the more it's off, the more wind you need. And then the more it's off, the faster you go one way and slower you go the other way. And then it's up to you to decide like, hey, is that something like I am comfortable with? Is that something that I like? And and from there you need to you can make a decision to fly. I particularly like flying, fast one way and crawling the other way. I don't mind that. I don't mind a bit stronger, but I've got a bit of a smaller wing as well that I fly on the beach. So you definitely have to look at, like, hey, if people are flying, doesn't mean it's good for you. Like if they're flying like mini wings or smaller wings. I don't fly a mini wing, but my wing is definitely a bit smaller than my normal size wing. So I can fly a bit higher wind speeds than if you fly just your full size, like a glider, for instance. On the coast, it's definitely worth keeping an eye on, like, hey, what's the forecast for gusts? And if there's gust forecast, either decide like, hey, it's too risky, or make sure you allow for those gusts by staying well out front of the ridge. So don't fly up and down like on top of the ridge. Try to fly as far forward as you can in where the lift band is still, if it's strong. And if those gusts come on and like the first one's a bit strong and you're sitting pinned, fly out and like just make sure you get your speed bar ready, and keep an eye out on the water. If there's white caps start coming on the water, like things start picking up and it might be a good time to land. If you're sitting on top of the hill and you get a gust and it's too much for your, even more than your speed bar can handle, then there's just nothing else you can do than go over the back and hope for the best, which you shouldn't, by the way. So watching the weather coming in, definitely important. Let's quickly go back to this slide. So that was the presentation I went through. As I said, I will generate a bit of a list of the links that I've used to the different sites that I use. Very much enjoyed doing it last night. I'm very happy there was a good turnout, and I'm very happy people were happy with the info. I hope we can do a bit more of these nights, like not necessarily like by myself, but as a lot of people that have a lot of knowledge in the little community that we've got. So it's good to get together and do something a bit out of only flying. So thank you very much for your attention, and have a good day. All right, so that's where I got to my fly sky high, which I will not go into.